we go to run a hypothesis test on two proportions, the first step, like always, is to go ahead and list our information. Because we'll have two samples, we'll make this list as sample 1 and sample 2. Because as proportions, we'll have P1 hat and P2 hat. Once again, you can choose either one to be sample 1. It doesn't actually really matter. I will always choose sample 1 to be the higher proportion so that when I subtract them, I get a positive value. After I list P1 hat and P2 hat, I'll list N1 and N2. I don't need to list a z-score, remember, because in reality, that's what we're going to find in step 3. That's our evidence. I do need to list the difference, though. So P1 hat minus P2 hat. Another thing that I don't have to list in two proportions that I listed in one proportion is P0. I don't have to list a P0 here because I'm going to assume, that's what P0 is, my assumption value. I'm going to assume the difference between these two is 0. So that's kind of like having, if we write over here, it's kind of like I have P0 equals 0, if you want to think about it that way. But because we're always assuming the difference is 0, I'm never actually going to write that. There is one new piece of information I need here when I'm dealing with two proportions, and that comes into play because I use P0 when I calculate SE for hypothesis testing. And because I don't have a P0 in here, I can't use 0 in the calculation of SE. I need a new value to use instead. And this is what's called the pooled proportion. The pooled proportion is what happens if we shove our two samples together. And because of this, there's a couple different ways to calculate it. Let's look at an example here. Let's say that out of 100 yellow cats, 60 prefer tuna. Out of 200 gray cats, 100 prefer tuna. Now, if I want to go ahead and list all this in order to do a hypothesis test, first thing I'd do is I'd make sample 1 and sample 2. Now, looking at these, I can tell that the yellow cats have a higher percentage, so I'd go ahead and make them sample 1. But once again, it doesn't really matter. So I'll write yellow here and gray here. For P1 hat, I'll have 60 over 100, or 0.6. For P2 hat, I'll have 100 over 200, or 0.5. And 1 will be 100, and 2 will be 200. I need to go ahead and calculate the difference as well. So moving this up, P1 hat minus P2 hat, and that'll give me 0.1. This tells me there's a 10% difference between my samples. The final thing I need to do is I need to find the pooled proportion. The pooled proportion is what I would get if I shoved my two samples together. So that is, if we think about it like this, I have a total of how many cats? Well, I have a total of 300 cats, right? And out of those 300, how many like tuna? Essentially, I've said, okay, I don't care about the color of the cat. Really, all I care about is cats in general. I had 300 cats, and out of those 300, 160 of them prefer tuna. So my pooled proportion here would be 160 over 300, or 0.5333. Notice that my pooled proportion is in between P1 hat and P2 hat, but it's not directly in between. The pooled proportion is actually weighted. That is, it's going to go towards whichever value has the highest sample size. So notice 0.5333 is in between, but it's closer to 0.5, and that's because this has our larger sample. Now this is how we calculate the pooled proportion if, once again, I have the actual counts. So I knew 60 of them preferred tuna, I knew 100 of them preferred tuna, so I just added them together. Let's look at an example where I don't actually have the counts of it. So restriction of information has been a big issue lately, and so one of the things we can look at is how do people feel about the government putting restrictions on information that's online. And so Pew Research actually did a study recently that asked, should the U.S. government take steps to restrict false info online, even at the expense of freedom of information. And they asked men versus women, they asked different economic groups, they asked different education levels. We're going to actually look at the age groups. So they asked 18 to 29-year-olds. And in this group, 31% of the 1,000 people asked said, yeah, they should. They should take steps to restrict false info, even if it limits freedom of speech online. Okay, so that was 18 to 29. Let's look at one group up. Let's look at 30 to 49-year-olds. For this group, they found that 36% of the 1,000 people asked said yes. Now, if we look at these two age groups, we can see there's a difference in our samples, but it's not an enormous difference. The question is, would this difference actually hold? That is, can we conclude that there's a difference in the percentage of 18 to 29-year-olds who feel this way and 30 to 49? To do that, we'd want to run a hypothesis test. We do our first step where we go ahead and we list everything, dividing our samples off. I would choose 30 to 49-year-olds to be sample 1 because they have a higher percent. But really, the only thing I want to practice here is finding the pooled proportion. Now, to go to find the pooled proportion, we need to first of all figure out how many people in total we had. Notice we had 2,000, and let's be specific here. The way I'm getting 2,000 is I'm adding the two samples together, right? So that's like taking N1 plus N2. Now, I don't know how many 18 to 29-year-olds felt this way, but I can figure it out. And that is, if I look up here, out of 1,000 people, 31% felt this way. And so to do that, I can just take 31% of 1,000. That is 0.31 times 1,000. And that'll give me the number of 18 to 29-year-olds who feel this way. I can do the same thing here. That is, I can go ahead and take 0.36 times 1,000. That'll give me how many 30 to 49-year-olds felt that way. After I find those two numbers, next thing I'll do is I'll go ahead and add them. Let's use this to go ahead and come up with a formula. I took 31%. That'd be the same as saying P2 hat times N2 plus P1 hat times N1, and dividing it all over N1 plus N2. So to summarize here, I have my formula for my pooled proportion, and that is my pooled proportion is equal to, I'm going to rewrite the order a little bit, P1 hat times N1 plus P2 hat times N2 all over N1 plus N2. Now, if we're going to plug into a calculator, it's a good idea to always put parentheses around things, so I can put a parenthesis there, and 1 there is there. Notice once again, I swapped the order. That is, I reversed this and this. But that's okay because addition is commutative. Reversing the order doesn't change anything.